Article 220.40b of the National Electrical Code addresses the number of meters allowed in a meter cabinet. For a 1200 amp service, the calculation to determine the maximum number of meters is as follows. The formula is total meters equals 4 plus 600 amps divided by 125 amps, or total meters equals 4 plus 1200 amps divided by 125 amps, resulting in total meters equals 4 plus 9, and then finally total meters equals 13. It is important to check the local electrical codes, as the 125 amp figure could be different, as local codes may differ from the NEC. With an existing meter center already containing 14 meters, that means 7 in each cabinet, adding another meter would violate Article 220.40b of the National Electrical Code. Each phase of a three-phase service is considered a separate service. A three-phase service with a 1200 amp main breaker could theoretically have a maximum of 18 meters, that is 6 per phase. But because each suite is running single phase, each meter is connected to only one phase. Thus, the maximum number of meters permitted remains at 13, as calculated using the previously described formula. To add power to a roof unit and adhere to the NEC and other local codes: 1. Install a new meter center with a larger capacity. 2. Utilize a main lug panel and distribute power to the roof unit with submeters. 3. Consult with the utility company to explore alternative metering solutions. It's important to remember that the National Electrical Code provides guidelines for safe electrical installations, and local amendments may exist. Always consult with a qualified electrician in your local authority having jurisdiction to ensure compliance with all applicable codes and regulations. Meter installations must comply with NEC Article 220.40b regarding the number of meters allowed in a meter cabinet, and this is based on the service amperage. The formula for calculating the maximum number of meters is as follows. Total meters equals 4 plus the service amperage divided by 125 amps. Using a 1200 amp service as an example, we get the total meters equals 4 plus 1200 amps divided by 125 amps. This simplifies to total meters equals 4 plus 9.6. Since you cannot have 0.6 of a meter, you must round down. Thus, the total meters equals 13. It's crucial to understand that the 125 amp figure in the equation is directly related to the service amperage, and local electrical codes might modify this value. Always confirm with local codes to ensure compliance. If an existing meter center already houses 14 meters, with 7 meters in each cabinet, adding another meter would directly violate NEC Article 220.40b. In such a scenario, you cannot proceed with the additional meter installation without addressing the code violation. In a three-phase service, each phase is treated as a separate service when considering meter capacity. A three-phase service with a 1200 amp main breaker has the potential to support up to 18 meters, with 6 meters allocated to each phase. This assumes an equal distribution of load across all three phases. However, if each suite within the building operates on a single phase, each meter taps into only one phase of the service. Even with a three-phase service, the maximum number of meters permitted remains constrained by the total service amperage and the single-phase usage. The maximum number of meters allowable is calculated as described previously at 13. When faced with the need to provide power to a roof unit while adhering to code restrictions, consider the following solutions. Firstly, install a new meter center with an increased capacity. This option involves setting up a separate meter center capable of accommodating the additional meter without violating NEC limits. Secondly, utilize a main lug panel and distribute power to the roof unit through submeters. In this approach, a main lug panel serves as a distribution point, and submeters are installed to measure the power consumption of the roof unit. Thirdly, engage with the utility company to explore alternative metering solutions. The utility company might offer specific metering arrangements or solutions tailored to your situation. Consulting with them can provide viable alternatives that align with code requirements. Always consult with qualified electricians and local authorities to ensure compliance with applicable codes and regulations. The National Electrical Code and local amendments are subject to change, so it is important to stay informed about the latest requirements. The information provided here is for general guidance only and does not constitute professional electrical advice. Proper planning, load calculations, and adherence to all relevant codes are essential for any electrical installation project. Firstly, a new meter center could be installed that has a larger capacity. This involves installing a completely separate meter center designed to handle the additional load and accommodate the new meter without exceeding the limits set by the NEC. This option offers a clean and compliant solution, especially when the existing meter center is already at its maximum capacity. Secondly, utilize a main lug panel and distribute power to the roof unit through submeters. In this setup, a main lug panel serves as a central distribution point. Power is fed from the main service to this panel, and then individual circuits are run to the roof unit. Submeters are installed on these circuits to measure the power consumption of the roof unit separately. This approach allows for accurate monitoring of the roof unit's energy usage without directly adding another meter to the existing meter center. Thirdly, engage with the utility company to explore alternative metering solutions. Utility companies often have specific programs or arrangements for situations like this. They might offer options such as virtual metering, where the roof unit's consumption is estimated based on other factors, or they might have specific procedures for adding new services in existing buildings. Consulting with the utility company is crucial to understanding all available options and ensuring compliance with their requirements. Prior to any electrical work, a thorough load calculation is essential. This calculation helps determine the actual power demand of the roof unit and ensures that the existing service and the proposed solutions can handle the additional load safely and efficiently. Load calculations must take into account all connected devices, their power ratings, and any applicable demand factors. It's important to note that simply adding a new meter without proper planning can lead to overloaded circuits, voltage drops, and potential safety hazards. A detailed load calculation provides the necessary information for making informed decisions and designing a safe and compliant electrical system. Always consult with qualified electricians and local authorities. Electrical codes and regulations are complex and vary from location to location. It is essential to work with licensed electricians who are familiar with the local codes and can ensure that all work is performed in accordance with the applicable standards. Additionally, contacting the local authority having jurisdiction, such as the building inspector or electrical inspector, is crucial for obtaining permits, scheduling inspections, and ensuring that the installation meets all requirements. Failure to comply with local codes can result in fines, delays, and potential safety hazards. The National Electrical Code is a comprehensive set of standards that governs electrical installations in the United States. However, local jurisdictions often adopt and amend the NEC to suit their specific needs and requirements. These local amendments can vary significantly from the national code, and it's important to be aware of these differences when planning and executing electrical work. Some common areas where local amendments might occur include wiring methods, grounding requirements, and overcurrent protection. Staying informed about the latest local codes and regulations is essential for ensuring compliance and avoiding potential problems. Always consult with local authorities and licensed electricians to obtain the most up-to-date information and guidance. Understanding the difference between single-phase and three-phase power is crucial when dealing with electrical systems. Single-phase power consists of a single alternating current waveform, while three-phase power consists of three alternating current waveforms that are offset from each other by 120 electrical degrees. Three-phase power is more efficient for delivering large amounts of power, and it is commonly used in industrial and commercial applications. In a three-phase system, each phase can be considered a separate source of power. This means that a three-phase service with a 1200 amp main breaker can theoretically supply power to multiple single-phase loads, with each phase supplying a portion of the total load. However, it's important to ensure that the load is balanced across all three phases to prevent overloading any one phase. Unbalanced loads can lead to voltage drops, equipment malfunctions, and potential safety hazards. Proper load balancing is essential for ensuring the safe and efficient operation of a three-phase electrical system. Article 220.40b focuses on the permissible number of meters connected to a service, especially in multi-tenant buildings. The NEC aims to ensure that the electrical load is safely and adequately distributed. This section prevents overloading the service conductors and equipment. The basic rule stated in Article 220.40b restricts the number of meters based on the amperage of the service. This limitation is not arbitrary. It is rooted in the understanding that each meter represents a certain amount of potential electrical load. By limiting the number of meters, the NEC is indirectly limiting the overall load connected to the service. This ensures that the service conductors, overcurrent protection devices, and other electrical equipment are not overloaded, reducing the risk of overheating, equipment failure, and electrical fires. The formula often used to determine the maximum number of meters involves several factors, including the service amperage and a constant value, often 125 amps. The constant value represents the assumed load per meter. By dividing the service amperage by this constant value, a maximum number of meters that can be safely connected is determined. This formula is a simplified approach to load management, and it is important to note that it may not always reflect the actual load connected to each meter. In some cases, the actual load may be higher or lower than the assumed load. This is why it is crucial to conduct a thorough load calculation before adding any new meters or loads to the service. In cases where the calculated maximum number of meters is exceeded, several options can be considered. One option is to upgrade the service to a higher amperage. This involves replacing the existing service conductors, overcurrent protection devices, and other equipment with larger capacity components. Upgrading the service can be a costly and disruptive process, but it may be necessary to accommodate the additional load. Another option is to implement load management techniques. Load management involves controlling and reducing the overall electrical load connected to the service. This can be achieved through various methods, such as installing energy-efficient appliances, using timers to control lighting and equipment, and implementing demand response programs. Load management can help reduce the peak demand on the service and allow for the connection of additional meters without exceeding the capacity of the service. Another option is to use submetering. Submetering involves installing separate meters for individual tenants or units within the building. This allows for accurate measurement of each tenant's electricity consumption, and it can encourage tenants to conserve energy. Submetering can also help identify areas where energy is being wasted, and it can be used to allocate energy costs fairly among tenants. Submetering can be a cost-effective solution for managing electrical load in multi-tenant buildings. When evaluating different options for managing electrical load, it is important to consider the cost, complexity, and effectiveness of each option. Upgrading the service can be expensive and disruptive, but it may be necessary in some cases. Load management and submetering can be more cost-effective solutions, but they may require ongoing monitoring and maintenance. It is also important to consider the long-term implications of each option. Upgrading the service may provide more capacity for future growth, while load management and submetering may require ongoing adjustments as tenants' energy consumption patterns change. To calculate the maximum number of meters, you must adhere to Article 220.40b. The formula for calculating the maximum number of meters allowed for a 1200 amp service is as follows. Total meters equals 4 plus the quantity of 1200 amps divided by 125 amps. This simplifies to total meters equals 4 plus 9.6. As you cannot have a fractional meter, it is always to round down, and in this case that means you are allowed a maximum of 13 meters in the service.